Hello, let's continue our Sudoku adventure with Scattered by Randall. So this concludes our indexing theme week. I was told to leave this towards the end of the week because it is a little bit on the harder side, but we will see how we do. Let's go over the rules. We have normal 6x6 Sudoku rules. So in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these red shaded cells in the grid. They tell you where some digit goes. Right, so let's think about it that way. They tell you where a digit goes in the same row as it. Now, what digit is it telling you about? The digit it's telling you about matches its column number. So this tells you about the 1, this tells you about the 2, this tells you about the 4, and this tells you about the 5. This would tell you about the 2. It's in column 2. These are columns 1, 2, 3, 4, 5, 6. So where does it go, though? How does it tell you where it goes? Well, that's the digit inside of it. So, for example, if this is a 4, the digit inside is a 4. This is telling me where the 1 goes because it's in column 1. Where does it go? It goes in column 4 because there's a 4 here. So we put a 1 right there. If, on the other hand, we put a 4 here, this tells you where the 2 goes. So there's a 2 in column 4. All right. And so that is how indexers work. We also have black dots in the grid. Black dots separate digits that have a 1 to 2 ratio. Rather, I should say the digits that are separated by a black dot have a 1 to 2 ratio. And so what that means is like one of them is exactly double the other. On a black dot, one of the digits is exactly double the other digit. So if this was 2, this could be 1 because 2 is exactly double 1. Or this could be 4 because 4 is exactly double 2. We have no negative constraints. So if there was a 2, 4 here, there's no black dot, that's fine. That could be the solution. Additionally, if we had, say, 4, 1 here, let's actually not intercept. Let's do 3, 1. If there was a 3, 1 here, these could have been shaded. But they're not, but that's okay. This could still be the solution. All right. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay. It feels like row 1 is the place to start. So my immediate thought is you can't put 5 on a black dot. And so the 5 ends up here or here. You can't put a 5 on a black dot because you can't have it to 2.5. And you can't double it to 10. That's an important property of black dots. So, right. And this cell here tells you where the 5 goes. But the 5 can only go here or here. So that can go in column 3 or column 6. And that makes this a 3-6 pair because 3-6 is one of the, basically across a black dot, you can only put 1, 2, 2, 4, or 3-6. The fact that this was only 3 or 6 forces the other to be the other 3-6. Now that this can't be 3-6, it is from 1, 2, 4. Now, this actually tells us where the 4 goes. All right, so this 3-6 pair tells us this is a 4-5 pair. Because if this was 3, then the 4 goes here. If this was 6, then the 4 goes there. And this would be the opposite. And so that this can't be a 4. So this is a 1, 2 pair. All right. And these will just tell, these work either way around. They either both self-reference or they reference each other. All right. So there's a 1, 2 here. There's a 3-6 here, for what it's worth. The next thing I'm seeing is this black dot here. You always want to chain off of something you found. So perpendicular black dots can't be the same as each other, right? This can't be a 3-6 because then we'd have too many 3-6s in this column. And so this has to be from the 1, 2, 4. It's either 1, 2, or 2, 4. And it does contain a 2, so that's not 2. All right. Now, this tells us about the 5 in this, sorry. Never mind. We can't have 5 on these anyway. I was trying to chain to this guy. Let's think about it. Hold on. Can this be a 4? Oh, right. That's what I was just thinking about. All right. If this was a 4, then this it is pointing at the 4. So it's forced to be a 5. We can't put a 5 on the black dot. So this is not a 4. So that means this is not 1, 2. If it was 1, 2, then we'd have too many 1, 2s in a row. So this is either 2, 4 or 3, 6. Now, let's think about 2, 4 first, because this tells us where the 4 goes. So if this was a 2, then the 4 would have to be here and here. That's no good. So it's not a 2. Now 4 would self-reference. That would be 2. We'll put a 3 there. That would be fine. So this could be 4 2 like that. So let's move that down so we remember it. Now let's look at 3 6 because this tells us where the 3 goes. So if this was 6, this would be 3, and then this would also be 3, and that's no good. So this can't be 3. So but then, sorry, was it the other way around? This can't be 6. 3 would self-reference. This would be 6, and that would put a 4 there. That's fine. So our options are just that. So this is telling us that the 4 goes in one of these two, and this is telling us that the 3 goes in one of these two. So now this does not have a 3 on it. Makes it from 1, 2, 4. It must contain a 2, which puts a 2 up here. So this can't be a 2. That's really weird how that worked. The 2, 3, put a 3 in one of these two, which forced one of these to be a 2, which then removed the 2 from here, making this a 3 and this a 6. Okay. Weird. That makes this a 3 and this a 6. The 3 tells us that the 4 goes there, and the 6 tells us the 5 goes there. This is not a 3. Okay. This has to be the 6 then. That makes this a 3, 6 pair. This is where the 5 goes. This is a 1, 2 pair, it looks like. All right, this is flowing really nicely. I might want to look at these, but is there any like simple Sudoku to do otherwise? Sometimes you just want to do as much Sudoku as you can before you start thinking about something hard, because it can give you more information. There's a 5 up here. I think we should think about this. There's a 2 in one of them. So if this was a 2, this has to be a 1. So this can't ever be 4. Right? Another way to put it is a 4 here would put a 2 here and a 2 there, as I was saying earlier. So that's not a 4, and that makes a 1, 2 pair. So this is from 3, 4, 5, 6. I'm doing this one because it's on an indexer. This is telling us the 2 is somewhere over here. I don't think that's helpful right now. This not being a 2 is kind of the key, but I don't think that does anything. All right. Can this be a 4? Yeah, we'll put a 1 here and a 2 there. Seems okay. So this is also from 1, 2, 4. Is there maybe this? This tells us where the 4 goes in the row. Could be 1 or 2. Can't be 3. Could be 4. Could be 5. Could be 6. Not 6. I really don't think that's helpful right now. What about this guy? It feels like there's something I should be able to do here. I don't know what it is. I mean, so one thing I'm seeing is we could potentially use a unique rectangle here, but forcing this to be a 4. But I don't like using uniqueness in these puzzles. And also, it's a little bit dangerous in variant puzzles to use uniqueness, because there could be some variant constraint somewhere that you're not seeing that would have resolved that, and it actually wouldn't be a uniqueness issue. So we're going to avoid that. This can't be 1, 2, and it can't be 3, 6. This is only 4, 5. Did I fail to, okay, I failed to place, okay, that's all it was. This 3 tells us that the 3 tells us the 3 is there. That's fine. The 6 tells us the 4 is there. That gives us the 5 here. And this is our other 1, 2 for the row. So this has to be 4. Okay. That's not 5 then. So if that's not 5, this can't be 4. That's a 1, 2 pair. That puts a 1, 2 pair here. All right, good stuff. Now this 4 tells us this is 2. 2 self-references, but the 4 places a 1 there. That makes that 2 and 1. That makes that 2 and 1. Wait, did I say that placed the 4? Hold on, I gotta go back. Wait. I got confused. This places the 2. So this can't be a 2. Sorry. That would have been a bad mistake. Okay, but I still think I did something down here. Yeah, the 4 places the 1 here, and that makes that 2. And the 4 also makes that a 2 directly. That's 1, that's 2. 2 could be with 1 or 4. Okay. This is a 3, 5 pair. Oops, I'm glad I caught that mistake. Sorry about that. That's 3, that's 5. That's not 1, that's not 1. There were a lot of ways forward from there, but I guess I found one of them. Oh, down up here we get the 2 and the 1. By the way, this did end up 4, so uniqueness would have gotten us the correct answer at least. This is 3, 5, 6. The 5 is one of these two. What are we doing with this information? Up here, we need the 1, 2, and 4. This is 2, 4, 5. 5 is one of these two. Oh, this is known. This is a 3. So these can't be 3. These one of these two. What about this one? This places the 2 in one of these. No, that works. This is 1, 2, 6. 6 is one of those two. All right. Everything's penciled. Is it one of these that I missed? This places the 4 in 2, 4. Okay, it doesn't place the 4 in the 5 there. All right, so then this is our 5. And then this is our 5. Now this was column 4, so this can't place a 2 in column 4, so that's not a 4. That places the 4 here. That's 2. We get the 1 and the 2. We get our 4, 1, and 2. That's 6, 1, and 4. I'm guessing this 3, 6 is resolved by the clue. This places the 2. Yeah, so that's 3, that's 6, that's 3, that's 6. All right. Cool puzzle, Randall. It actually flowed really nicely. This little interaction in this box was really neat. I still don't quite get it. I mean, I kind of get it, but like indexing is weird like that. We're like reducing this to 2, 3, reduced this to having to have a 2 on it. Therefore, this has to be 3. That was a neat deduction. All right. Well, let me know how you did. I hope you enjoyed the indexing theme week. We always eventually have more indexing puzzles scattered through our normal puzzles. So now maybe you'll have better tooling to deal with those. And if you did enjoy this, why not leave a like, subscribe, and a kind comment below.